According to the National Electrical Code, any lighting fixture installed within 6 feet of a sink requires ground fault circuit interrupter protection. This requirement is in place to minimize the risk of electrical shock in areas where water is present. It is important to understand the scope of this rule to ensure compliance and safety. The 6-foot distance is measured horizontally from the edge of the sink. This means that any part of a lighting fixture falling within this zone must be GFCI protected. The rationale behind this is that sinks are inherently wet locations, increasing the potential for electrical hazards. If a fault occurs in a lighting fixture, the GFCI will quickly trip, cutting off the power and preventing a potentially dangerous shock. While the specific increase in receptacle height from 18 inches to 20 inches may be relevant to outlets, it does not directly apply to lighting fixture requirements. The 6-foot rule is a general provision for lighting near sinks. It is also crucial to consider the type of sink when applying this rule. This requirement typically applies to sinks in kitchens, bathrooms, and other areas where water is regularly used. The specific code section that outlines this requirement can be found in the National Electrical Code. Consult the latest edition of the NEC for the exact section number. The NEC is updated every 3 years, so ensure you are referencing the most current version. There are several ways to provide GFCI protection to a lighting fixture. Firstly, you can use a GFCI circuit breaker. This breaker will protect the entire circuit, including the lighting fixture. Secondly, you can install a GFCI receptacle upstream of the lighting fixture. This means that the lighting fixture is wired to the load side of the GFCI receptacle. Thirdly, you can use a GFCI protected switch. This switch will provide GFCI protection to the lighting fixture. When selecting a GFCI device, ensure that it is rated for the intended use. For example, if the lighting fixture is outdoors, you will need to use a weatherproof GFCI device. Regularly test GFCI devices to ensure that they are functioning properly. Most GFCI devices have a test button that you can use to verify their operation. If a GFCI device fails to trip when tested, it should be replaced immediately. It is also important to consider the type of wiring you use for the lighting fixture. If the wiring is exposed to moisture, it should be rated for wet locations. This will help to prevent corrosion and other damage that could lead to electrical hazards. When installing a lighting fixture near a sink, always follow the manufacturer's instructions. This will help to ensure that the fixture is installed correctly and safely. If you are not comfortable working with electricity, it is best to hire a qualified electrician. An electrician will be able to properly install the lighting fixture and ensure that it is GFCI protected. They can also verify that the wiring is up to code and that the installation is safe. In addition to the NEC requirements, there may be local codes or ordinances that apply to lighting installations near sinks. Be sure to check with your local building department to determine if there are any additional requirements. Failure to comply with these requirements could result in fines or other penalties. It is always best to err on the side of caution when it comes to electrical safety. If you are unsure about whether a lighting fixture needs GFCI protection, it is best to consult with a qualified electrician. They can assess the situation and provide guidance on the best way to ensure safety. Ground fault circuit interrupters work by monitoring the current flowing in a circuit. If there is a difference of more than a few milliamperes between the current flowing into the circuit and the current flowing out of the circuit, the GFCI will trip. This difference in current indicates that some of the current is leaking to ground, which could be a sign of an electrical fault. GFCIs are designed to trip very quickly, typically in less than 1/30th of a second. This is fast enough to prevent serious injury or death. There are two main types of GFCIs: receptacles and circuit breakers. GFCI receptacles are installed in place of standard electrical outlets. GFCI circuit breakers are installed in the electrical panel. Both types of GFCIs provide the same level of protection. When choosing between a GFCI receptacle and a GFCI circuit breaker, consider the specific application. GFCI receptacles are typically used to protect individual outlets, while GFCI circuit breakers are used to protect entire circuits. If you're only protecting a single lighting fixture, a GFCI receptacle may be the best choice. If you are protecting multiple lighting fixtures or outlets, the GFCI circuit breaker may be more appropriate. It is also important to consider the cost of each option. GFCI receptacles are typically less expensive than GFCI circuit breakers. However, GFCI circuit breakers can protect multiple outlets, which may make them a more cost-effective option in some cases. When installing a GFCI device, always follow the manufacturer's instructions. This will help to ensure that the device is installed correctly and that it will function properly. Always turn off the power to the circuit before working on any electrical wiring. This will help to prevent electrical shock. Use a voltage tester to verify that the power is off before you begin working. Wear appropriate safety gear, such as gloves and safety glasses. This will help to protect you from electrical shock and other hazards. If you are not comfortable working with electricity, it is best to hire a qualified electrician. An electrician will be able to properly install the GFCI device and ensure that it is safe. In addition to protecting against electrical shock, GFCIs can also help to prevent fires. Electrical faults can generate heat, which can ignite flammable materials. GFCIs can trip quickly enough to prevent this from happening. It is also important to note that GFCIs do not protect against overloads or short circuits. Overloads occur when too much current is flowing through a circuit. Short circuits occur when there is a direct connection between two conductors. Overloads and short circuits can damage electrical equipment and can also cause fires. To protect against overloads and short circuits, use circuit breakers or fuses. Circuit breakers and fuses are designed to trip when the current exceeds a certain level. This will help to prevent damage to electrical equipment and can also help to prevent fires. Regularly inspect electrical wiring and equipment for signs of damage. Look for frayed wires, cracked insulation, and loose connections. If you find any damage, have it repaired by a qualified electrician. Do not overload electrical circuits. Overloading a circuit can cause the wires to overheat, which can lead to fires. Use power strips with surge protection to protect the electronic equipment from power surges. Power surges can damage electronic equipment and can also cause fires. Keep electrical cords away from water. Water can conduct electricity, which can create a shock hazard. Do not use electrical appliances in wet locations. If you must use an electrical appliance in a wet location, use a GFCI protected outlet. Teach children about electrical safety. Explain the dangers of electricity and how to avoid electrical shocks. By following these safety tips, you can help to prevent electrical accidents. Remember, safety should always be your top priority when working with electricity. If you have any questions or concerns, consult with a qualified electrician. Ensuring that undercabinet lighting meets NEC standards for GFCI protection is crucial for homeowner safety. The 6-foot rule regarding sinks applies regardless of the 18-inch to 20-inch change related to receptacle heights. Always prioritize safety when working with electrical components. It's also worth clarifying different types of lighting and their common applications to contextualize the undercabinet scenario. Firstly, incandescent lighting is a traditional option, known for its warm color rendering but is less energy efficient compared to newer technologies. Secondly, fluorescent lighting is more efficient than incandescent, often used in commercial spaces and sometimes in kitchens, emitting a cooler light. Thirdly, LED lighting has become increasingly popular due to its high energy efficiency, long lifespan, and versatility in color, temperature, and design. It's commonly used in undercabinet lighting for its focused and efficient illumination. Then halogen lighting provides a bright, white light similar to natural daylight, often used for task lighting, but it produces more heat than an LED. It's important to remember that wiring methods need to be compliant. Firstly, non-metallic sheath cable, commonly known as Romex, is often used for residential wiring, but its suitability depends on local codes and specific installation conditions. Secondly, electrical metallic tubing, or IMT, is a metal conduit that provides physical protection for wiring, commonly used in commercial and industrial settings, and can be suitable for certain residential applications requiring more protection. Thirdly, flexible metal conduit, or FMC, is a flexible conduit used for connections to motors or other equipment where flexibility is needed, and it's also used to protect wiring in tight spaces. And finally, armored cable, or AC, consists of conductors wrapped in a flexible metal sheath offering protection against physical damage, suitable for concealed wiring in walls and ceilings. Another key factor is understanding ground fault circuit interrupters. Firstly, a GFCI monitors the current balance between the hot and neutral conductors in a circuit. Secondly, if there's an imbalance indicating leakage current to ground, the GFCI quickly trips, cutting off power to prevent electrical shock. Thirdly, GFCIs are required in areas where electrical outlets or devices are near water sources like kitchens, bathrooms, and outdoor locations to enhance safety. Grounding is another concept to grasp. Firstly, grounding provides a low resistance path for fault current to return to the source, helping to trip the circuit breaker or fuse and clear the fault. Secondly, proper grounding ensures that metal enclosures of electrical equipment are at a safe potential, reducing the risk of electric shock. Thirdly, grounding systems include grounding electrodes, grounding conductors, and bonding connections to create a safe electrical environment. And surge protection is essential as well. Firstly, surge protection devices protect electronic equipment from voltage spikes or surges that can damage sensitive components. Secondly, surge protectors divert excess voltage away from the equipment, preventing damage from lightning strikes, power outages, or other electrical disturbances. Thirdly, surge protection can be implemented at the service entrance of a building and at individual outlets to provide comprehensive protection. When working with electricity, always remember safety precautions. Firstly, always turn off power at the circuit breaker before working on any electrical circuit or device. Secondly, use insulated tools to prevent electric shock and protect against accidental shorts. Thirdly, wear appropriate personal protective equipment, including safety glasses and gloves, when handling electrical components. Another area to consider is the National Electrical Code. Firstly, the NEC provides guidelines and regulations for safe electrical installations, covering wiring methods, overcurrent protection, grounding, and other aspects of electrical systems. Secondly, local jurisdictions often adopt and amend the NEC to suit their specific needs and requirements, so it's important to comply with local codes. Thirdly, staying updated with the latest edition of the NEC is essential for electrical professionals and anyone working with electrical systems to ensure compliance and safety. In residential wiring, there are specific considerations. Firstly, branch circuits supply power to outlets, lighting, and appliances, and they must be properly sized and protected with circuit breakers or fuses. Secondly, circuits are typically rated for 15 amps or 20 amps, depending on the load requirements and the wire size used in the circuit. Thirdly, dedicated circuits are often required for appliances with high power consumption such as refrigerators, microwave ovens, and air conditioners to prevent overloading the circuit. Another point to remember is electrical boxes. Firstly, electrical boxes provide a safe enclosure for wiring connections, protecting them from damage and preventing accidental contact. Secondly, boxes come in various shapes and sizes to accommodate different wiring configurations and devices. Thirdly, boxes must be properly sized to provide adequate space for conductors and devices and must be securely mounted to structural members. Wiring connectors are also important. Firstly, wiring connectors provide secure and reliable connections between conductors, ensuring proper electrical conductivity and preventing loose connections. Secondly, connectors come in various types, including wire nuts, terminal blocks, and crimp connectors, each suited for specific applications. Thirdly, proper installation of wiring connectors is essential to maintain the integrity of electrical circuits and prevent overheating or arcing. Another point to consider is electrical permits. Firstly, electrical permits are required for many electrical installations, ensuring that the work complies with local codes and regulations. Secondly, obtaining a permit typically involves submitting plans and specifications for review and undergoing inspections to verify compliance. Thirdly, working without a permit can result in fines, delays, and potential safety hazards, so it's important to obtain the necessary permits before starting any electrical work. Another important aspect is electrical inspections. Firstly, electrical inspections are conducted by qualified inspectors to verify that electrical installations comply with codes and regulations. Secondly, inspections typically involve checking wiring methods, grounding systems, overcurrent protection, and other aspects of the electrical system. Thirdly, passing an electrical inspection is essential to ensure the safety and reliability of the electrical installation and to obtain final approval for the project.